Namaste everyone. Welcome back to my class again. And this is our second class in mechanical properties of solids. So in the previous class, we were discussing about the plastic and elastic behavior of materials. So as you see on your screens now, this is going to be our objective today, to define stress, to define strain, and to understand the different types of stress and strain. So let me move in to talk about stress first. This has nothing to do with the stress that we are going about now in this pandemic situation. That a solid is going to be subjected to, right? Now, what is stress? If you remember, I showed you a rubber band in the previous class, which was pulled out, and we showed a knife that was bent and a dough that was pulled up apart. What were we trying to do? We were trying to apply a force on that object, right? And when we applied a force, think about the rubber band once again. When I pulled the rubber band, I applied a force. And when I released my hand, what made it regain its original shape? So there was a case where I applied, there is an applied force on the body, right? When I released the applied force, what made the body regain its original shape? The restoring force, right? The restoring force from inside. What did it restore? Why am I going to call it as a restoring force? Because it restored, it regained its original shape. So this applied force is what we are going to call it as the deforming force, because I'm trying to deform the shape of the body. And when the deforming force is going to be removed, there is a restoring force that's going to come into action. Now, what is the beauty between these two forces? These two forces are going to be equal and opposite to each other, and we are going to denote them by the common alphabet F. So we are going to define stress as the force, the deforming force or the restoring force that's going to act per unit area of the body. Doesn't this seem familiar to you? Just pause the video and think, what is F by A? Have you seen this anywhere in your lower classes, children? Yes, you are right. This is nothing but pressure, right, children? Force per unit area is nothing but pressure. If I have to put it in a much more pinpointed way, it was thrust per unit area that you did in your lower classes as pressure. That's what we are going to come again over here too. But for now, we are going to define stress as the deforming force that's going to act per unit area of the solid, applied on the solid under consideration. So let's move on to define stress now, because that's our main objective here, to define stress. What is meant by stress applied? So how are we going to define it? The deforming force, okay, the deforming force acting per unit area of the solid, sorry, per unit area matlab yahan pe this is per unit area of cross section of the solid. Please understand, the deforming force acting per unit area of cross section of the solid is termed as stress, okay, right? That is what we are going to call as stress. Now, if I'm going to take up stress, what is our next objective is to describe the different types of this stress. So I'm going to put up over here 4 different types of stress. The first one, I'm going to call it as tensile stress. And the next one, I'm going to call it, the next one I'm going to call it as contractile stress. Yeah, compressive stress. Let me put it. Compressive stress, tensile stress, compressive stress, and the other one is going to be hydraulic stress, and the last one is going to be tangential stress, tangential or shear stress. So these are the 4 types of stress that we are going to talk about: tensile stress, compressive, hydraulic, and tangential. Now, what's going to be tensile stress? We will going to take one at a time. The first one, tensile stress. If you apply a deforming force on the body in such a way that it goes to increase the length of the body, so obviously it is the tensile stress that you apply on a rubber band when you stretch it, right? So what's tensile stress? The stress that increases the length of the body is what we call as tensile stress. So what is the example? The deforming force per unit area applied in stretching a rubber band is what we call as tensile tensile stress. Now, what is compressive stress? What can I call, which stress can I call as compressive stress? So any idea, children, what can I call as compressive stress? Obviously, to compress something. So what is compressive stress? The stress that decreases the length of the body. For example, what can I say? Example, the deforming force per unit area applied in pressing a sponge or in pressing a syringe. Syringe is not will not regain its original shape, but yes, you do it, right? Like, at least we can take it as an example where you reduce the length by applying a force on it. So by pressing on a sponge. But I can't say sponge because I'm going to put in hydraulic as the bulk in more directions. So the deforming force per unit area applied in pressing, what can you contract by pressing? Along the length only. Whose length can you decrease by pressing it? A spring. Why can't I put a spring? That's correct. The deforming force per unit area applied in pressing a spring, that becomes compressive stress. Now, what is the third one that we said, children? The third one is what we called as hydraulic stress. Now, what is that? The stress that is applied in all directions around a body. That is, which actually brings in a change in its volume by applying a force on all directions of the body. That's why I removed the sponge from the previous example. So the deforming force applied on a sponge, when you just crush it, when you press it, that becomes hydraulic stress. That is the stress that you apply from all directions. Now, what's the last one that we saw? That's the tangential stress. What is, or that is otherwise called as shear stress. Now, what is a shear stress? Now, let me show you this book that I'm holding in my hand. Any book of this matter. You see, these 3 sides are mutually perpendicular to each other, right? The height and the length are mutually perpendicular to each other. Now let us assume that I am going to apply a force parallel to this surface, right, in such a way that one of the face that is actually perpendicular moves. If I push it like this, can you see, children? Can you see that if I apply a force in this direction, the rectangle, if I'm going to call this face as a rectangle, the face that is actually a rectangle, if I'm going to apply a force parallel to the face of the book, can you see that it changes to become a parallelogram. Is that clear? That is what is a shearing stress. Say, for example, this is the face that I'm talking about. You apply a force parallel to the surface, that the book becomes like this. So this angle through which it turns, that's the shear strain that we will discuss when we are doing strain. Now this force that you apply parallel to the surface, creating a change in its shape, is what we call as shear stress or tangential stress. So what am I going to write here? The stress that is applied parallel to the face of the body, right? In such a way that a face that was perpendicular to another gets inclined due to the stress. That's what we call as a tangential stress. Please get one thing very clearly. Whether it is tensile stress or compressive stress or hydraulic stress, these all come under the category of normal stress. Normal ka matlab kya hai? What do you know about normal? Normal means perpendicular, right? So in all these cases, the force is going to be applied perpendicular to the area of cross section. Just imagine your rubber band to be a cylinder, right? If you take the area of cross section, that's a circle, right? And when I pull it, when I stretch it, the direction of application of your force is perpendicular to the circular face. Yes or no, children? So that is what we call as a normal stress, whether it is tensile, whether it is compressive or hydraulic. The force that you apply is perpendicular to the area of cross section. F is perpendicular to A in these cases. Whereas if you look at tangential stress, F is parallel to the face. F is parallel to the area of cross section. You call such a force per unit area as tangential stress. So what are the four types of stress that we have seen here? Tensile stress, compressive stress, hydraulic stress, and tangential stress. All these stress have your SI unit as Newton per meter square, or the famous unit, that's Pascal. That's the same as your pressure. Is that clear? Now we move on to strain. What's strain? Strain is a dimensionless physical quantity. That means it's a ratio, basically. It's a ratio of the change in dimension to the original dimension created by the stress. So I'm going to put it up over here. It is the ratio of the change in dimension to the original dimension created by the stress applied. Okay, it is a ratio of the change in dimension to the original dimension, where the change is created by the stress applied. That's what is strain. Okay, a change by original value is what we call as strain. Now this strain, again based on the stress applied, is of three types. The first one is called linear strain, otherwise called as longitudinal strain. Okay, so that's the first strain. And then the other one is called as volume or bulk strain. And then the last one is tangential or shear strain. I'm not even going to use the word tangential. I'm going to straight away write, because I've already told you what is meant by shear. So shear strain. So what is going to be the change that is going to be created by your tensile or compressive stress? It is the change in the length. So what's going to be linear strain? Linear strain is going to be del L divided by L. The change in length to the original length is what we call as longitudinal strain. This is going to be created either by a tensile stress or by a compressive stress. Now volume stress or volume strain. What stress will create it, children? Obviously hydraulic stress. So this is going to be the change in volume by the original volume, because this stress, which dimension is it going to change, or which physical quantity is it going to change? Not necessarily dimension, because it changes all the dimensions, length, breadth, height. So which quantity does it change? It changes the volume. So it becomes del V by V. And what happens to my shear? My shear is theta. That is the strain. The shear strain is what we call as theta. And this is going to be given by, if I'm going to take this face, I'm going to show you this again. If the strain is going to create a change theta, and if this displacement is del L, and if this length original is L, this is again going to be del L divided by L. But these two are different. Please understand this very carefully. In this case, del L is the increase or decrease in length to the original length, while in this case, this is going to be the displacement of the parallel face to the length to which it was perpendicular to. If these the alphabets are going to be of any confusion to you, then you can change your longitudinal strain to be with a capital L, while your shear strain and stress, you can keep it with a cursive L. So these are the three different kinds of strain. Please understand there is no unit, because it is a ratio of the change to the original dimension. So we have three depending on the stress. So depending on whether it is tensile or compressive, we have linear strain, otherwise called as longitudinal strain. And based on hydraulic stress, we have volume strain. And based on tangential stress, we have shear strain. Is that clear, children? So I will go back to my first slide where I wrote the outcome. So what's going to be the outcome? Do you think we have achieved this outcome? Will you be able to state what is stress and what is strain? Stress is the force applied per unit area on a body to deform its shape or size. And what is strain? The change in the dimension, the ratio of the change in the dimension to the original value due to the stress applied is what is called strain. And what are the different types of stress? 4 we saw: tensile, compressive, hydraulic, and shear or tangential. And based on this, we saw 3 strains, that is longitudinal or linear, volume or bulk, and finally tangential or shear strain. I hope these outcomes have been achieved by us based on the objectives that we had. That's for today's class. In the next class, based on this stress and strain that we have seen, we are going to study a relationship between them based on a law called Hooke's law. Till then, you should be thorough with the different types of stress and strain, and make sure that you keep in touch with the subjects and do watch the videos regularly rather than keeping them to be watched in one go. We will meet you in the next class with Hooke's law. Till then, stay safe.